Objective, real numbers. Let's start with some definitions. Definition number 1, irrational numbers are non-repeating and non-terminating numbers. So the most common example is pi. You can have other numbers that just continue on and don't have a pattern. So non-terminating means they don't end, and non-repeating means they don't have a pattern. So no repeating decimals would be an irrational number. Definition number 2, rational numbers. These are the opposite of irrational numbers. So if you have a real number, it is either irrational or rational. It has to be one or the other. A rational number is any number that can be expressed as a ratio of two integers. So let's recall, what is an integer? An integer is a positive and a negative whole number and 0. So if it's a positive whole number, if it's a negative whole number, or if it's 0, then it's an integer. So let's go back to rationals. Any number that can be expressed as a ratio of two integers, two positive or negative whole numbers and 0. Now remember, you can never have 0 in the bottom of a fraction. Ratio is a fraction. Whole numbers. Whole numbers are natural numbers and 0. Well, what's a natural number? A natural number is a counting number. So natural numbers would be starting with 1, 2, 3, 4, 5, 6. The basic numbers that you first learned. Whole numbers include 0. Natural numbers do not. Integers include whole numbers and natural numbers, so they also have 0. Definition number 3, a counterexample. An example would be something that shows something is true. A counterexample is any example that proves a statement is false. Definition number 4, absolute value is the distance a number is from 0 on the number line. Classifying real numbers. Name all sets to which each number belongs. So we have some examples. Example number 1, negative 17 over 31. Well, all of these numbers are real numbers. All numbers are real numbers except for imaginary numbers, which we haven't discussed yet. So first category you should know is the biggest category, real numbers. Now, this number can be expressed as a ratio of two integers. Negative 17 is an integer, 31 is also an integer. A fraction bar means it's a ratio. So this is a rational number by definition. Now, it's not a whole number, it's not an integer, it's not a natural number. Okay? So if it's rational, it can't be irrational. Remember, it can either be one or the other. Example number 2, 23. 23 is a real number. It is also a rational number. It can be expressed as a ratio of two integers. Whole numbers, you can put them over 1. So 23 and 1 are both integers. This is a ratio, so it's a rational number. 23 is an integer. It's a positive whole number. It's not 0, so it's also natural. You can count to 23. Example number 3, 0. 0 is real. It is also rational. You can still put 0 over 1. 0 divided by 1 is 0. 0 is an integer. Remember the integer's definition, positive and negative whole numbers and 0. It is a whole number. All the natural numbers plus 0. However, it is not natural. When we count, we don't start with 0, we start with 1. So it's not a natural number. Example number 4, the square root of 2. Now, if you type in the square root of 2 in your calculator, you get 1.41, it keeps going, okay? This number doesn't have a pattern, and it doesn't stop. It continues on. Now, your calculator is only going to hold a certain number of digits, but know that this number will continue on. We learned how to approximate the square root of 2 using division and estimating without a calculator. So you would be able to continuously find the next decimal place if you were doing this by hand. not able to be expressed as a ratio of two integers. So therefore, it is an irrational number. If it's irrational, then it cannot be rational. Okay, it's not a whole number. There's a decimal. So it's not an integer, it's not a whole number, and it's not a counting number. Example number 5, 3.14. Now, commonly, you use 3.14 to approximate pi. However, this is just 3.14. Pi continues on forever. If you see the 3 dots, that's an ellipse. It continues on. Here we don't have that. So this is just 3.14. Well, it is real. It is also rational because it can be expressed as a fraction. A terminating decimal, right? It goes 0.14 at the end. So it's rational. Integer. It is not an integer. There's a decimal portion of this. There's part of it left. So it's not whole either, and it's not a natural number. This is just real and rational. Example number 6, square root of 36. Well, hopefully you know that the square root of 36 is 6. So these are equivalent to each other, so they are going to fall in the same sets. Real. 6 could be over 1, so rational. It is an integer. 6 is an integer. Square root of 36 is an integer. Whole. And natural. We can also count up to 6. All right. Which set of numbers is most reasonable for the situation? So example number 7, the number of students that will go on the field trip. Well, the number of students that will go on a field trip, you can't have half a student or a decimal portion of a student. You have to have a whole number of students. You can't have negative students, so it's not integers. And you could have 0 students, so it's not natural. Your answer is going to be whole numbers. These would be best to approximate the number of students that will go on a field trip, whole numbers. Example number 8, the height of a blade of grass. Well, every piece of grass is different, and they all grow at different rates and different sizes. So the height of a blade of grass doesn't have to be 1 inch or 2 inches or 4 centimeters. It could be a portion of it. It could include fractions and decimals. Include fractions and decimals. And I'm going to abbreviate this. So, which type of number includes fractions and decimals? You have to think more generally. Rationals include fractions and decimals. Integers, whole numbers, and natural numbers do not include fractions or decimals. And the opposite of rational is irrational, so that can't be true. Counterexamples. True or false is how we're going to answer 9 and 10. If false, give a counterexample. All whole numbers are integers. All whole numbers are integers. So if you think about the definition of whole numbers are natural numbers and 0. They fit into the category, which is bigger, integers. So yes, this is true. All whole numbers are integers. We can say that the whole numbers are a subset of the integers. Example number 10. No fractions are whole numbers. No fractions are whole numbers. Well, this might be counterintuitive, but it is false. In a previous example, we said 6 can be written as 6 over 1. 6 over 1 is equal to 6, and this is a whole number. So, no fractions are whole numbers. That is not true. Fractions can be whole numbers, and whole numbers can be fractions. Finding absolute value. Vic number 1, the distance can never be negative. Never. absolute value always describes a positive value. So, you know, these two bars denote absolute value. The absolute value of 12 is 12. 12 is 12 places from 0 on the number line. The example number 12, absolute value of negative 3. Absolute value of negative 3 is 3 because negative 3 is 3 places from 0 on number line. Example number 13, absolute value of negative 3.7 is positive 3.7. Remember, taking the absolute value means taking that sign away, finding out how far it is from 0. Example number 14, now we can do operations with absolute value. Remember order of operations, instead of saying parentheses, we say enclosures. Absolute values bars are enclosures. So we do what's inside first. 3 minus 1 is 2. So we have the absolute value of 2 now. Well, the absolute value of 2 is 2. And now we can add. 4 plus 2 is 6. Remember, we do enclosures before multiplication and division, addition and subtraction. Okay. Example number 15. Absolute value of 24 plus absolute value of negative 4. Absolute value of 24 is 24. Absolute value of negative 4 is positive 4. Add 24 plus 4, 28. Example 16. The absolute value of the quantity, negative 6 plus 4, minus 3, the absolute value of 3. So let's do the inside first. Negative 6 plus 4 is negative 2. This 3 can carry down. It's still inside the absolute value until we take it. Absolute value of negative 2 is positive 2. Absolute value of 3 is 3. This minus sign carries down. Now let's do the subtraction. 2 minus 3 is negative 1. And that's all.